Hello, this is Abir, and in this video, we will learn about the introduction to blockchain. So, in this video, we will have the understanding of the high-level concept of blockchain, and we will learn five basic topic of blockchain like hash cryptography, immutable ledger, distributed peer-to-peer network, mining, and consensus protocol. So, without further ado, let's begin. Let's discuss from what is blockchain. So, according to Wikipedia, there is a generic definition about blockchain. So, it says a blockchain is a continuously growing list of records called blocks which are linked and secured using cryptography. So, a blockchain is a chain of blocks. So, what the block holds? A block holds these three functionalities, and each block acts as a fingerprint for its own. Each of the block has a data, previous hash, and hash. So, hash means each of the block has a particular code for its own. So, each block can be represented or can be taken as a particular hash function or a number, and previous hash means each block has the hash of its previous block. Hence, it completes a chain of blocks because each block has the hash of the previous block, and this is how the chain works. So here we can see that data is stored in each of the block, and the hash is like a fingerprint of each block, as I said earlier, and each block has its own hash and the hash of its previous block. Now, let's go further. And we can see that this is a simple view of a blockchain. We can see that there are three blocks of the blockchain and there are more, and this means that the blockchain is connected with every block. And we can see each of the block has data, previous hash, and hash. And the first block of a blockchain is called the genesis block. And the previous hash value of the genesis block is obviously 0 because there is no block before it, and it has its own hash. Then coming from block 2, we can see that the hash value of genesis block is the previous hash value for block 2, and block 2 has its own hash. Again, the same is applicable for block number 3. So maybe you have taken a simple understanding about the blockchain, how blockchain is built, and now we will go the deeper concept of blockchain. A blockchain is related with these five topics. We should know hash cryptography, immutable ledger, distributed peer-to-peer network, mining, and consensus protocol. So let's go and understand each of the topic step by step. So let's come to hash cryptography. We will learn SHA-256 hash in this particular video. So we all know that every single person in the world has his own fingerprint. So we can say that a fingerprint is an identifier for a person. But can we think that this for digital things like PDFs, documents, even operating systems? Yes, we can take the same principle and apply it to digital documents. How? This is how hash cryptography works. So we can use PDF, text, audio, and even an operating system and convert it to a hash number. So SHA-256 does a hashing technology and produces a fixed length unique hash value from an input of any size. Here, the any size line is very important because the length of the input can be any size, but the output, I mean the hash, is always has a 16 character length. And the output hash is a hexadecimal hash. That means it has numbers from 0 to 9 and the letters A, B, C, D, and E, and F. And as I said, you can put anything digital like video, text, audio, even an operating system into the algorithm and it will spit out a fingerprint, which means a unique hash for that particular document. Now, there is a screenshot from the website tools.superdatascience.com where there is a demonstration how each data is converted to a hash. You can check this out. You can write anything here and a hash value for that data will be shown. So it produces a fixed length 256-bit unique hash value from an input of any size, and hashes are unique to each input, even a minor. This is a very important line that the hashes are unique to each input. Doesn't mean the size of it, doesn't mean the characteristics of it, nothing. Now, we come to the avalanche effect, which means like there is a line that I am teaching SHA-256 hash. If we make a little bit difference, like if we change this H to another character, we will see a significant amount of change in the hash. Like a single change in the data will create a major difference in the hash value. And this particular this particular characteristic is called the avalanche effect. So, and again, another characteristics of SHA-256 hash is it's impossible to reverse engineer the input from the hash. Yes, if you have the hash value, you can never determine the data from it. Yes, this is how the hashing implements. You can never get the data from the hash value. And another characteristics of SHA-256 hash is the same input always produces the same hash. That means anytime you write this data, you will get this particular hash for this. But remember the avalanche effect. If you change a minor character here, you will get another hash completely different from this one. Okay, isn't it cool? Yes. Okay. Now come forward and see 5 requirements for hash algorithm. Number one way, which means, as I said earlier, a doc can generate a hash function, has a hash number for it. But as I said, the hash cannot generate the doc. Or if I say it simply that you can easily get the output from an input, but from the output you can never get the input from it. Another one is deterministic. As I said earlier, that each of the input will have a particular output for it. The output for a particular input is always fixed. How much you will write it again and again, you will get the same input for it. The third one is fast computation. You will need to compute the hash from an input very fast. Again, the third one is the avalanche effect. You can see that this is a doc and this is the output of the doc. And if you change a little minor change here, you will get a significant amount of change in the hash. Third one is must withstand collision. Yes, a hash can also make a collision. How? Look, you have a fixed length of 16 character and each of the character can have 0 to 9 and A to F for each. So after a long number of time, you may see a repetition of the hash, but this is very rare condition. And here you may feel weird why there is a picture of a pigeons. And you may guess it that it follows pigeonhole principle. How? If all possible combination of the hash is done, then we will start from the very beginning. And like this compartment of the pigeon, two input will have a same hash. And here we can conclude that SHA-256 hash follows a pigeonhole principle, while there is a numerous inputs. Again, another thing is which if a doc has a particular hash and if somehow by pigeonhole principle or anyhow we can make another doc and we can manipulate it by that doc, this should be never ever possible. But if there is any chance of doing so, the hash function fails. So every hash function should always think that there can never be an opportunity that the any other input can access the hash and know the input from it and manipulate the hash. This is basic and very important character of any hash function. So now let's get back to a new topic of blockchain technology, which is very important, which is called immutable ledger. For that, let's think of a scenario that you have cash and you want to buy a house and you have bought the house. But how can you know that you own the house? Or mean how the house is associated with you? So the solution is what our government do is you write a deed. You write a deed that this house is for you. You have bought this house with your money, and this deed is sent is reserved to the government. The government has a copy that this house is by you. So the government has a notepad or anything physical book where written that this house is bought by you. So to register, the authority writes it down in a physical ledger. What if the book is hacked? It means, in real sense, what if a disaster, natural disaster comes and the book is destroyed, is burnt down, or is lost? So here we can think of a digitalization of this process. So in context of blockchain, every time somebody buys something or sells a house, it's a new block that is added to the chain. So as it is digital and it is not stored in any physical entity, so there is no possibility that the your deed is lost or you have bought the house, this information is lost. So here comes the immutable ledger part. You can see there is a blockchain and each block of this blockchain has some information about transaction like you bought this house, this is in this block, and after you buy the house, there are more information about transaction and each of these block has the information of that transaction. Like you can see that after you bought this house, there are more transactions and each of them are stored in the next blocks. So now your house ledger is stored in a block of the chain and so others so that the chain is growing larger. Now let's think it from a hacker's perspective. If a hacker wants to tamper the data in that specific block of your ledger, which means this specific block is the hacker wants to tamper this specific block that you have bought the house, the hacker have to change the hash of that block. So if a hacker wants to tamper the data of your block, he needs to change the hash value of that block. So now the next block has the hash of the previous block of it. So we have learned that if he has to tamper the data of this block or tamper the hash value of this block, sorry, not data, he has to change the hash value for the next block also. Why? Because the next block has the hash value of the previous block. Because as we know, every block has the previous hash value saved in it. So if the hacker hacks the no, or temper the hash value of this block, he has to temper or change the hash value for this block as well. Also, this block as well and this block as well until the end of the blockchain. So if the hacker has to tamper data from from this first block, he has to change the hash value from all of the blocks. This is not so easy thing to do in blockchain world. This is written the same thing here. The hacker also need to change the hash of that particular block. Similarly, the hacker has to change the hash of all blocks from the one he started. And this is not an easy thing to do for the hacker. And this concept of saving each transaction in each block of a blockchain is called mutable ledger. And the you may understand the word immutable meaning here. Immutable means you can't mutate it or you can't change it. A hacker can change it so easily. As we have seen, it is easily changed or easily can be updated in physical format. Because in physical format, there can be a person who can change your name from the deed that is saved to the records into the government. They can be many corrupted people, but this is not possible in the world of blockchain. So here, we can see that immutability means that once data is recorded in a block on the blockchain, it cannot be altered without altering all subsequent blocks. As I said earlier, this feature ensures tamper resistance, trust, and transparency. Tamper resistance means any malicious change is detectable because if someone changed this hash but he can't change the next hash, so it can be easily detectable. Okay, we can see that there is a graph of total UK residential property transaction. So we can see that the number is very high, not seasonally adjusted or seasonally adjusted. We can see that both of the two graph is almost very high. So if you want to if you want to store the values in a physical notebook, it is too tough for the government to store it. So it's easy for implementing a blockchain technology where the transactions of property can be stored and which is also safer than physical notebook. So, with blockchain's immutable ledger, every transaction is permanently recorded and verified. If historical property data are stored on a blockchain, auditors and stakeholders could trace and verify each data point without fear of manipulation. So, I hope you have understand the immutable ledger concept very well. Now we will go to our next segment, which is distributed peer-to-peer network. In distributed peer-to-peer network, we will take the concept of immutable ledger to the next level. So here we consider that maybe the hacker has enough time to alter all the hashes of each block. And except from this, not only for hackers, a block may have some issues for the data in it and or it can be tampered or lost by any outside things or outside catalyst. So this is where the concept of distributed peer-to-peer network system arrives to solve the issue. So in a distributed peer-to-peer network system, there are lots of computers and each of the computer are connected. And it may sound crazy, but let's think how the blockchain are delivered or the blockchain is accessed to the computers. Yes, it's so weird to think that the blockchain are copied across all the computers. Yes, each of the computer has its the blockchain. It has the blockchain. This one has the blockchain. This is written here. The blockchain is copied across all the computers. So it's not like that there is a blockchain and the computer has access. This computer has access of that blockchain. This computer has access of this blockchain. This is not like that. This is not like that. There is a blockchain. This is a blockchain. This computer accesses this blockchain. This computer also accesses this blockchain. This one also accesses the blockchain. This is not like this. This is not the concept of blockchain, you know. So what happens here? Here, the blockchain is dedicatedly provided for each of the computer. Okay, so what is our key takeaways from now? That a distributed peer-to-peer network has lots of computers and each computer is connected to each other and the blockchain is copied across all the computers. Okay, now let's think that if a computer's blockchain has a new block of its. So let's think that here is a new block of this computer. What will happen that this blockchain has a new block to it, and the neighbor computer like this one will see that this blockchain has less block than it. So this block will be delivered to this block as well. This will get the same block just like this. The every other blockchain of the other computers will get the same block. This one will get the same block. This one the same block. This one get the same blocks. And this one the same blocks. And hence the blockchain for the entire system will be maintained, as you can see from here. Okay, this is the thing that is written in the next slide. You can see that this is a new block and this block is distributed among all the computers here. Once a new block is added, that information is communicated throughout the network and the block is added further through the network until all the computers have this block. Okay, now obviously after adding this block, there will be more block that will be added to that blockchain. Obviously, after months, more blocks will be added to the chain, and now the problem arrives. What is the problem? The problem is that let's think that there is a hacker, and this hacker wants to tamper the data of this block. And this and he has successfully tampered the data of this block. And as we know earlier, it is not sufficient to only tamper the data of this block only. He has to tamper the data of all the blocks from this one, this one, this one, and this one. And we think that all of it is possible for the hacker to tampering all these blocks. We take it that it is possible somehow. There is a person who has enough time to do so. So now, what will happen? Now, look at that. This computer's blockchain will see that this blockchain has these blocks to it. The neighboring computer like this, it will also have this part, and another neighboring will have this part. But this blockchain does not have this part. So what will happen that this computer will say, hey, I have this part to myself, but you don't have it. This will also say, I have this part, but you don't have it. And this is how this blockchain will be copied to this blockchain. So what I'm trying to say that even if a hacker tampers the data from this block until the last one, the connected blockchain or the connected computer's blockchain will see that the data is tampered to that computer's blockchain, and they can send this data to the computer, and this tampered blockchain will be restored. So then it will also get all the blocks from it, and it will also be connected like this. And this is what is written here. If somebody tries to hack out entry and changes all the hashes to the end, like as I discussed, these are all tampered. The distributed peer-to-peer network makes all the computers synced up and constantly checks if the blockchain of these peers match up. So, as I said, this computer will see, this computer will see, this computer will see that these blocks are tampered, and instantly the other computers connected through the red lines, which means this one, and this one will see that there is a problem and their blockchain does not match with the blockchain of the affected computer. So the blockchain of the affected computer is the minority and the majority of blockchains around it are consensus. So as I said, what will happen? The corrected blockchain will be copied to the affected blockchain and the chain will be corrected. As we can see that here the blockchain is affected, the hacker is affecting the blocks of this blockchain, and as this blockchain will change this blockchain and we will get the corrected blockchain again. So the set for this block hacker, his attempts are all in vain. So sad for him. So you can read about it furthermore to this particular link, Medium link, to know more about distributed peer-to-peer network. Okay, now we will understand how mining works. So first of all, let's revise what is the properties of a block in a blockchain. As I said earlier, in a block, there is a data. There can be multiple data here, and there is a previous hash which holds the hash value of the previous block and the hash value of its current block. So why there is the actual fuss? Why a miner will mine blocks? So what a miner will do, he will try to find the hash of a particular block. The actual work of a miner is he will try to find the hash value of a particular block, and if he can find the hash value, he can be a winner, which means he has successfully mined a block. As you may heard that a miner uses lots of electricity, lots of currents, like a whole thing. He may expend millions of dollars, thousands of dollars for mining blocks. Why? We will see this right now. Until now, we have discussed that a block has these three values. But there is a new character or a new thing in a block of a blockchain, which is called nonce. What is nonce? Let's find out. So there is another field, nonce. It stands for number used for only once. This is the field where mining is all about. In mining, everybody just changing this field all over the time. So what actually happens that the block number, the value of nonce, data, and the previous hash, all these four fields are fed to the hash function. And these four values generates a hash value, and this hash value is set for the miner, say for the hash of that particular block. Now, if you think that the block number of a blockchain is static, it means it can be changed. The data of the hash of the block is also can be changed, and the previous hash can't be changed as well. So if we know the block number, data value, and previous hash, we can generate the hash value easily. But is it so simple like that? No. Here comes the actual play of the nonce. The nonce is nothing but some integer or long numbers, which means 1, 2, or any number it can be. And according to this nonce value, the different hash values are generated. Nonce value can be 1, 2, adding to anything. So every value for nonce, we will get a new hash value for the block. So we put all the four components into the hashing algorithm four component means block, nonce, data, and previous hash, and get the hash value. As I said earlier, nonce gives us extra flexibility because we can manipulate the hash value by changing the value of nonce. As I said earlier, we can only manipulate the value of nonce, not the value of block, not the value of data, not the value of previous hash. We can only change the value of nonce. So different value of nonce generate different hash. Here we can see that the block number, data, previous hash are same for all these four particular examples. Here as well. The only thing that are different here are nonce. Here nonce value is 19 and we are getting a particular hash for this value. Here nonce value is 20 and we are getting another hash value for this. Here nonce value is 21 and we are getting this hash value, and here nonce value is 23 and we are getting this hash value. So we see that we can change the value of hash by changing the value of nonce for each of the block. Now let's think how, or let's know how a miner mines a block, or how he gets the hash value of a particular block of a blockchain and mines a block. Before that, let's agree on this particular line that a hash is a number. Let's agree on this. How? Because let's see, this is a hash. This whole thing is a hash. As I said earlier, that SHA is a hash value, is a hashing method, and it generates a hexadecimal number. And we all know that hexadecimal can be converted to a normal integer. And obviously, integer is a number, and we can agree on the fact that a hash value is a number. So this is a hash value, this is a hash value, this is also a hash value. And every hash value is converted to its corresponding integer values, or a number, not integers. So as these all are numbers, we can put this on a number list where we can sort them from the smallest to the largest. Like this value is a small number and it is putting down here, it is indicating this place of the hashing mechanism or the hashing diagram, and this is a like larger than this, so it will locate here, and this is the largest, so it will locate here. So we have agreed that a hash is a number, and these numbers can be sorted in ascending order. So we can sort them in this whole thing, and we can locate this hash value on a particular diagram or a particular hashing diagram. So here we will learn a new thing, that target. So what is the target? The blockchain algorithm sets a target. The target is set from the miners to accomplish a certain hash. So in this whole diagram, from the smallest to largest, particular part is called the target. So the target is located, is indicated by this part only. This is the target. So if a miner wants to mine a block, he has to find the hash number for the from the target region. If he finds outside of the target region, this will not work. Now you may ask, why we need to use target? Why target? The answer is, there is no mathematical, no logical, nothing logical reason for this target. The main reason of using target is just making the thing more complex for the miner to find it more difficult ways, because it is not a very easy thing to do. It will not be a very easy thing to learn blockchain. So a miner has to do very difficult computations, his computer has to be more powerful. You may heard a miner uses supercomputers that is worth the millions of dollars. He pays computer bills or electricity bills on thousands of dollars. So this is the why he has to find a hash value, and this hash value should be in the target region. And as I said that this hash value has to be defined by nonce value. So what a miner do, he has to compute different nonce value and checks if this nonce value is that if and he checks if the generated hash from this nonce value is inside of the target or not. So what is the flow? First of all, a miner he gets a particular nonce by randomly. There is no sequence. He finds the nonce value from it can be 1, 2, 3, or any other number, and this nonce value generates the hash value and checks if it is greater than target or less than target or equal to target. If the generated hash value is less than target or equal to target, then he is considered as winner, or he has found the block, or he has successfully mined a block. So any hash higher than target does not count. If you find a hash above the target, it is not worthy for you. It has to be below the target, as I said earlier. So this is the target. This is the target. This is the values that is larger than target, equal or less. So the miner has to work with this region. If he finds a value, if he let's think he has selected a nonce value, assume this is equal to 3, and he has generated a hash value from this nonce. And if this hash value is like here, then this mining won't work. He has not computed it below the target. But let's think nonce is equal to 2. For the value of 2, we will get a hash value. And let's assume this hash value is inside the target. So this time, this miner is a winner. He has successfully won this hash, guessed this hash, and he has successfully mined this block. So this is how mining actually works. So let's see here that any hash higher than the target does not count. We have said it. Now let's go to the next slide. Miners changes the value of nonce and checks if the hash is below the target. If a nonce generates a hash below target, it is a golden nonce. So in this previous example, the value of nonce is 2, and here we have generated the hash which is under the region of the target. So we can say that nonce value 2 is a golden nonce. So we can see that there is a block, and this block has data, previous hash, and a hash. So what a miner will do, he will check for different nonce value. He will check for different nonce value like 23, 21, 22, 143, 76941, and for the nonce value of 5012, he will generate this hash value, and it will be the under the target value. So here who can know that here is written a thing that target is 0000, which means the miner can get a hint that the target starts with 0000. So he will get to know that the hash value starts from 0000. So he will try to find a nonce value that generates hash value with leading four zeros. And this is the tip. Express will target with leading zeros. This is written here. So as we discussed here, this thing is written here. You can understand this from here. That's how mining works. So let's summarize how mining works. I have said that a block has data, previous hash. Then I have revealed that a block also has a new thing which is called nonce, and this value of nonce is used to generate hash value because block number, data, and previous hash is static for a particular block, and changing this nonce value will change the value of hash, and a miner will predict the value of hash, and for predicting a hash, he has to change the value of nonce, and different number of nonce produces different hash values, as I see it here, and you can look here, and he has to generate multiple value of nonce and generate a different hash for each nonce value, and if the value of hash is inside the region of target, then he is considered as a winner, and the nonce is called as a golden nonce, and if it is not, then he is not a winner, or the mining is not completed. So this is a very big or very large concept of blockchain, that how mining works, what miners actually do. So you can discuss with it, you can research on this topic about how miners do. So let's go to the next segment, next part of blockchain technology or blockchain introduction, which is called consensus protocol. A consensus protocol is a block in a blockchain is like a group of friends agreeing on the same rules for a game. How? Let's imagine you and your friend are keeping score for a game, but there is no referee. There is no referee, which means there are nobody to implement that the rules are implemented perfectly or not. So everyone has to agree on the score, but there is no referee. So in blockchain, every computer checks and agrees if a new transaction is fair and correct before adding it to the big book, which means the blockchain. The rules everyone follows to agree are called the consensus protocol. So this is very important thing, that the rules every computer follow is called the consensus protocol. As I said earlier, that where it was like that every computer has its own blockchain, and each blockchain is related to each other. So each of these computer are agreed on the rules of blockchain, and these rules are called the consensus protocol. And this consensus protocol makes sure nobody cheats, and the scores, which means the transactions, can be changed later. Example: the consensus protocol has certain examples like proofs of work or proof of stake. Proof of work means imagine you are solving a really hard puzzle to prove you deserve to write the score, which means you have done a lots of things. You have a lots of achievement, you have solved lots of puzzle. So you have gained the ability that you deserve to write the score because you have done a lots of things. You have accomplished lots of things in your life. So why not everyone will believe you? Everyone must believe you because you have done lots of things. Another one is proof of stake. It means you get to write the score if you put some of your points to the risk to show you are serious about playing fair. Which means think that you have 10 points. You're saying no, I will give 2 points from my point and I will have 8 points. Now believe that I will play fair because I have sacrificed 2 of my points from myself. So I must play fair because I don't have 2 points. I have sacrificed from myself. So why not I should play fair? So this two topics covers consensus protocol of blockchain technology. So this concludes the 5 topics of blockchain, which are very important to understand blockchain. If you want to learn blockchain, you have to understand these 5 topics very well, because without this, you won't be able to understand the basic transactions of blockchain. There are more topics of blockchain, like you need to understand smart contracts. You need to learn a new programming language called Solidity. You have to learn ICO, initial coin offering, and all of learning after all of this, you will understand how blockchain development work. So this is it. I hope you have understand very well. Thanks for watching this video.